So we'll continue with logarithms, and now we're going to solve equations in log form. And we're going to do this without a calculator. So first we're going to take this and put it into exponent form. 5 to the x power equals 125. So 5 to what power makes 125? So 5 times 5 is 25, times another 5 is 125. So that 125 is the same as 5 to the third power. So 5 to what power makes 125? The third power. So x must be 3. Again, exponent form, 4 to the x equals 1 over 16. Now what I did here was I made both of these a base of 5. This time I want to make them both a base of 4. So 4 to the x equals 1 over 16 is 4 squared. So 4 to the second power. And I can move that to the numerator by changing the sign on the exponent. 4 to the x power equals 4 to the negative 2 power. So x equals negative 2. And last on this page, 8 to the x power equals 4. Okay, so I want to get those in the same base, and I really can't make this a base of 4 or a base of 8, and I can't make this a base of 4, but 8 is 2 to the third power, and 4 is 2 to the second power. So now they are in the same base. So raising a power to a power, that's 2 to the 3x equals 2 squared. So this exponent, since they have the same base, must equal this exponent. 3x equals 2. So x is 2/3. Okay, so all of these is where x is the argument. Where x is the exponent. So for 7, 8, and 9, and then for 10 also, x is the exponent. After that, it's going to change. So we've got 6 to the x power equals 6 times the square root of 6. So 6 to the x equals 6 to the first power times 6 to the 1/2 power. So if I add this, since I'm multiplying, 1 plus 1/2, that's 3 halves. 6 to the x equals 6 to the 3/2 power. So x is 3 halves. Okay, so from 10 back to 9, 8, 7, x is the exponent. Starting here, x is the base. So x to the 6th power equals 64. So the x is in a different spot now. Okay, so what number times itself 6 times makes 64? That number is 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. That's 6 of them. So 2 to the 6th power equals 64. So x must be 2. But there's another number times itself 6 times that makes 64, and that is negative 2. So x can be positive or negative 2. X to the 3/2 power equals 27. Now another way I could have solved this one is by moving this power over to here, and I would have gotten x equals 64 to the 1/6 power. I'm going to do that here because I'm not really great with doing things to the 3/2 power in my head. So I'm going to move that over here and have x equals 27 to the 2/3 power, the reciprocal power. And that is the same as 27 to the 1/3 power squared. That's something I might be able to solve. So 27 to the 1/3 power means something times itself 3 times to make 27. We're looking for the cubed root of 27. And what times itself 3 times makes 27? That number is 3. So it's x equals 3. And we still have to the 2nd power. So x is 9. So next is x to the negative 4/3 power equals 16. So I'm going to bring that over here, and it's going to be the reciprocal power. X equals 16 to the negative 3/4 power. And I'll split that up just like I did right here. So x equals 16 to the 1/4 power to the negative 3rd power. So what times itself 4 times makes 16? That would be 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So x equals 16 to the 1/4 is 2. And then we still have to the negative 3rd power. Now if I don't want a negative power, I can move this down from this numerator down into the denominator. So it's over 1, and I can move this down here. I'll have x equals 1 over 2 to the positive 3rd power. And 2 to the 3rd power is 8. So 1 over 8. And when I get to 14, it changes again, where now x is the argument. So 7 to the 2nd power equals x. Now 7 squared is 49. X is 49. I think having it in the argument is the easiest of these to solve. X to the 2/3 power, 8 to the 2/3 power equals x. Okay, so this one, I'll split up that fraction. So it's x, I did it again, 8 to the 1/3 power squared equals x. What times itself 3 times makes 8? It's 2. 2 to the 2nd power equals x. And 2 to the 2nd power is 4. (27) to the negative 4/3 power equals x. So I'll split that up again. 27 to the 1/3 power to the negative 4th. What times itself 3 times makes 27? 3 times 3 times 3 is 27. So 27 to the 1/3 power is 3. And I have a negative power, so I need to move this down to a denominator to have a positive power. So that's 1 over 3 to the 4th power. So 3 times 3 is 9, times 3 is 27, times 3 is 81. So x is 1 over 81. And number 17 is 2/3 to the 2nd power equals x. I need to raise the numerator to the 2nd power, and the denominator to the second power. Okay, so we've got a different type of logarithmic equation now, where there's a logarithm on both sides. So notice that these two have the same base. I've got a base of 7 and a base of 7. I have that over here also. Base of 4, base of 4. When the bases are the same, I have equal arguments. So this argument equals this argument. X equals 25. Same base, equal arguments. 3x plus 2 equals 10. I can subtract that 2. 3x equals 8. And divide by 3. X equals 8/3. And my last two equations, now I have different bases. Okay? So I'm going to split these up. Log base 2 of 8 equals some number. And since log base 2 of 8 and log base 3 of x equal each other, they both equal the same number. I can solve this. So 2 to the n power equals 8. 2 to what power equals 8? 2 times 2 times 2 is 8. So n is 3. So this right here has a value of 3. So 3 equals log base 3 of x. In exponent form, 3 to the third power equals x. 3 times 3 times 3 is 27. So x equals 27. So by putting the n here, what I really do is just evaluate that side so I could set this equal to some number. And I'll do the same here. Different bases, I'm going to split them up. Log base 4 of x equals some number, which also equals log base 3 of 9. If I try to solve this part right here, I'm going to have an x and an n. So I'm going to solve this over here where I only have one variable. So I'm evaluating log base 3 of 9. 3 to the n power equals 9. 3 times 3 is 9, so 3 to the second power is 9. So n is 2. So this has a value of 2. So log base 4 of x equals 2. 4 to the second power equals x. So x equals 16.